بسم الله والصلاة والسلام على رسول الله. In this lecture, we will be talking about life acquisition and memory analysis. So what does actually life acquisition mean? Life acquisition means collecting evidence while the computer is actually up and running. And this is very important because some data only exist in the memory and they disappears once the computer is turned off. So when there's, for example, a cyber attack, sometimes the clues are hiding themselves in the RAM. And if we turn off the computer, those clues will vanish, will disappear. So if we need to collect the evidence before, uh, we need to collect the evidence before shutting down, and this will happen through the life acquisition. So after we do the life acquisition, we extract the memory. It will be a memory, a sample of a memory. So we will perform some analysis that help us to extract some clues. And then this is the forensics value of the forensics where the forensics comes here. So we will perform life acquisition, collecting the memory, and then we will try to analyze the memory to see what is inside the memory, what are the processes affected, is there any password, what are the network connections. We will see a lot of things in there. So for example, imagine that you walk in a kitchen and someone is baking cookies. So if you walk in while they are cooking, you will see the flour, the chocolate, the dough. But if you come after they finish and they clean up everything, the kitchen will look normal. So no sign of these cookies. Memory is similar to this. So it's like the kitchen counter. If you want to know what's happening, we need to look while the baking is still going on, not after we cook everything. Okay, so in this, inshallah, lecture, we will learn how to perform life acquisition, what can we find in the memory, how can we find the processes in the memory, etc. What are the forensics value of memory analysis? What can we get from there? Actually, memory contains of a lot of a process. So what are these processes? What are the processes there in the memory? What are the main process running by the system? Because there is a user process and the system process. How can we differentiate between them? What is actually Process Hacker? Process Hacker is a tool similar to like that shows all the up and running processes, so we can differentiate between the legitimate and or the suspicious and the benign process. So we can tell that, okay, this process is actually normal, but this process is abnormal. This process is benign and this process is actually suspicious. So we will use a Process Hacker as a tool. And then there are several processes in the memory. We need to understand the profile. It's kind of a fingerprint for each process. And I will present at the end the mind map that combines all the different types of processes together. So first of all, about performing life acquisition. The first statement here, it says that life acquisition are especially useful when you are dealing with active network intrusion or attack. What do we mean by active? We mean by active is that if there is a real-time incident that is occurring right now, performing life acquisition is the best solution. We might later need actually to collect the hard disk drive data, etc. But the first thing that we need really to consider at this moment is the life acquisition. The network intrusion, if there is, for example, a network intrusion or any type of attacks, and they are active and up and running, we will perform the life acquisition. Also, the second statement says that life acquisition done before taking the system offline are also becoming a necessity because attacks might leave footprint only in running a process or RAM. What does that mean? This means that some attacks leave no traces on the hard disk drive. They only leave the traces in the memory, and they disappears when the system or when the device shut down. So we need to really, it is very important and necessary to acquire the RAM because it leaves some attacks leave some traces in the RAM. But when you turn off the device, it will leave nothing in the hard disk drive. Also, there is another important aspect when we perform the life acquisition. It says that life acquisition don't follow a typical forensics procedure because after you do a life acquisition, information on the system hasn't changed because your action affect RAM and running process. What does that mean? This means that when I do the memory acquisition or the life acquisition, I need to run an application. This application, whether this is FTK, whether this is another platform, this actually application is a process. And when I run this forensics application, if I run this forensics application, this means that I am adding several processes to the memory. So I am affecting the memory. However, we need to keep these changes to the minimum. We need to not overwhelm the memory with a lot of applications. So for example, if I would like to perform live acquisition, I should carefully run any application. I should only focus on the digital forensics application and reduce the usage of any other applications to not overwhelm the memory. I will show you something here. For example, I will, for example, open the task manager. Task manager show all the processes, all the process here, also the application. So when I open any application, let's say, for example, I will open, so this is, let's say that or I will open here process hacker. There are a lot of processes here. Okay, so do you want to terminate? Okay, so whenever I open anything or any application, let's say I will open Paint. So new process will be actually open in these in the process hacker. So let's say that, for example, I open the Internet Explorer search. And if I open anything in you, as you can see, it was in green. So whenever I open anything, a new process will be created and so forth. So let's say I close it, for example, and then I open. See, it becomes red. So when I try to open it again, I will see a new process with actually with green. So here's the paint that I open here. This is one, this is the one, this is the process hacker. So how this is related to our sentence. Our sentence says that whenever we are performing life acquisition, we need to reduce number of steps to not add more process to the memory. So we need to be very careful about choosing the application we are going to run to acquire the memory. Okay, there are several tools that are very important in life acquisition, and one of the most important tool called volatility tool. Volatility is actually a very popular and free tool used to analyze the memory, and it helps investigators actually see the learning process, open file, connections, sometimes the passwords that has been utilized while we are opening some files. So if I have, for example, for example, if I have a file and this file is actually password protected and I open it and it requires to write my password, this actually password will be saved, it will be written in the memory. So if I perform live acquisition, I might be able to see this password. So volatility is actually exists in Kali Linux. So Here's, for example, I will show you here. So actually you can like install it. If it's not installed, you have to install it. And then this is the volatility folder. And in order to run the volatility application, I have to type Python 3, and then volatility.python, and then -h for help. So it will tell me all the things related to the volatility. So I will type, and then it will show you all the things here. So volatility, -c for configuration. I can, for example, type, for example, these are all the things that comes with volatility, all the options. Um, so I can use all the options with the volatility in order to analyze a specific memory. So I have to type volatility.python and then put the memory that I would like to analyze. So -f file where I can like add the file that I want to analyze. Okay. So this is one of the important tools. There are other tools for sure, but volatility such as Lime to capture the memory, etc. But volatility is the most common tool. Another thing that we need to consider when we are performing the memory analysis is to understand the order of volatility concept. The order of volatility concept already introduced in the acquisition chapter. So we mentioned that it is the order of volatility is the priority list of what data disappears faster. So some information like the RAM vanishes very quickly. Other like hard disk drive, no, it takes longer time and stay for longer time comparing to the memory. Okay, so although we mentioned that there is no typical forensics procedure to acquire the RAM, however, there is some kind of recommended step when we are performing the live acquisitions. So there are several steps. I will mention them right now. And the first step is actually not always applicable. So the first statement says that create or download a bootable forensic CD or USB. This is very important. Imagine that an attack happened or there is a memory affected, there is a malware affected Khalid device. And I would like to capture the memory of Khalid device, okay? So Khalid does not have any tool installed to capture the memory. So what will I do? I need to have kind of a bootable forensic CD or USB. How can I do this? I can do this using CAINE. It is a Linux operating system. I can download it and put it in a USB and make this USB bootable and then insert this USB to Khalid device, and then this this CD will be running, and I have a lot of forensics tool, and then I can acquire the memory. I will show you here CAINE. So this is actually CAINE. So it's Computer Forensics Linux Live Distribution. And actually, there are a lot of tools there. So here are a list of tools. So okay, these are the added or changes tool comparing to the previous one. But there are a lot of tools such as memory dump, ADB, hex editors, and many other tools for forensics analysis. So you can. So what's CAINE actually? CAINE is Linux distribution. It's a very lightweight one. The newest version is a lightweight. and you can actually download it. So you can download it, and once you download this, you can put it in a USB and make this USB bootable and insert it into the suspect device where his device is affected by a malware. So you can easily perform the acquisition itself. Okay, but the point here is that this is useful only if the malware is persistent. So why if the malware is persistent? Because if I insert a USB, this means that I have to turn off the computer, right? Because I have a bootable USB means that I have to turn off the computer and then turn on the computer to boot from the USB, not from the affected operating system. So if I turn off and turn on the device, this means I will lose everything in the memory. So, but if the malware is actually persistent and affect the memory all the time, even if we turn on the device and turn off the device, this means that I can like utilize the bootable forensics CD or USB to acquire the memory. So we need to be very careful about this because we will not always do this. Uh, because if I do this and the malware will be vanished after I turn off the device and I boot from a USB, I will lose everything. Okay. But if the malware is persistent, this means that even if I turn on the device, I will be able to see the processes related to the malware. Okay. Another thing is that while we are performing the live acquisition, we need to make sure that we keep a log of all our action. This is kind of chain of custody. We need to write down every single thing. Also, we need to consider the source and the destination. So a network drive is ideal as a place to send the information you collect, or you may use a USB. So now I have let's say I have here a device. So this is a Khaled device. So sometimes I need to insert bootable forensics CD. Why? Because this bootable has a lot of forensics tool, okay? But this is not always. Another thing, network device or a USB, why to acquire, after I acquire the memory, I have to put the data into a USB or I have to send it via network to save the memory. Actually, the memory usually ends with .mem. So if I acquire a memory, it will be end with .mem. So it will be file.mem, malware.mem, memory.mem, or whatever. A copy of the physical memory. So actually, this means that I have here the memory itself, or I can take another color. Let's say that here's the memory. So the memory itself, I should have the memory itself. So this memory will be actually stored in a USB or it will be transferred to a network device. You might want to see whether a rootkit is persistent by using tools such as rootkit revealer, and there are many other tools. So, okay. So actually, I can, for example, I want to use not the highlighter or not the laser. I want to click on this. This is a rootkit revealer. You can upload any memory to it, and it will tell you whether this is actually a rootkit or not. So this is one of the tools that help you. So actually, Rootkit Revealer is an advanced rootkit detection utility. It runs on Windows XP and Windows Server, and its output, it lists of registry and files, system API that may indicate the presence of a user mode or kernel mode rootkit. So it will tell you just about this type of malware. Create an image of the drive over the network or shut down the system. shut down and make a static acquisition later. So after I have after I have the USB or after I have the RAM and I put it into a USB or send it via network, after that I have to shut down the system and then also take a static acquisition for the hard disk drive because some malware might affect also the hard disk drive. So the first thing we need to consider the memory and then the hard disk drives. Be sure to get a forensics hash value of all files you recover during the live acquisition. So this is important to ensure the integrity later and to ensure the integrity of the files. So how can we perform the live acquisition? There are several tools actually to perform the live acquisition. We can use, for example, FTK Imager. And FTK Imager, there is a green button here. When we press on it, actually, it will collect the actual memory exists on the device. So this is how can we capture the memory using FTK Imager. What can we find actually in the memory? There are a lot of things. We can find the running processes. We can find some password keys and other information. We can see some live chat, login information, malware presence, including even rootkit. We will see what are kind of connections to a network, etc., and many other things. To simplify everything, I can show you something here. Mm. Mm. This is actually an example of analyzing one of the malware called Stuxnet that affect one of the largest critical infrastructure in Iran. So they use volatility to analyze these Stuxnets. So what is Stuxnet? Stuxnet is a malware, and they took a sample of the affected devices and they use volatility tool. So actually, for example, I will show you here. So we said, okay, Python, volatility, and then the file, which is the memory, is stuxnet.vmem or .mem. So this is the file. This is the file that we captured. And then we said PSS scan. So it will check all the process and it will print all the processes running in the memory from the sample. So all the processes running, it will be shown here. And later we will check whether these processes are actually legitimate, benign, normal, or these processes are actually not legitimate or suspicious process. So there are a lot of things that we can find in the memory. Anything that the processor works upon. So what are the forensics value as well of memory analysis? Malware has to run, and of course, this malware is being executed in the live memory. But there is a noise in the RAM. For sure, there is a noise of the RAM. How can we differentiate between normal activities and abnormal activities? Now, let's say that I am here. Let's say I am actually, okay. So let's say I am opening my Windows and I will open this. This is a process hacker that shows all the processes. So let's say that there is a noise, means that there is a lot of processes. How can I differentiate between the normal and the abnormal? It is not that direct. However, there are some key processes that will help us tell whether there are a clean version of the memory or there are some processes that are affected in the memory. So whenever I run any application, for example, any application such as, let's say, Microsoft Edge, I will see here new processes up and running. When I open, for example, anything, I will see new processes running. So there are a lot, whatever I open, whenever I open anything, it will create a new process. Let's say I open the recycle bin, I open, let me open some applications. For example, let me open Paint, new process, open and running. Let's say that I open this, let's say that, hmm, I open, for example, calculator, and calculator, maybe it's a Trojan. It shows that it is a calculator, but let's say that it is kind of, there is a malware hidden inside. So when I click it, when I click on it, it seems like a normal calculator. But if this is actually a malware, um, and there are some legitimate process regarding to the user activity, and there are some malware, let's say this one, how can I differentiate? There are a lot of noise in memory. There are a lot of processes in the memory. So you need to filter down through the RAM noise and to be able to look for legitimate process from suspicious behavior. What are the normal, legitimate, acceptable process, and what are the suspicious behavior here? How can I differentiate between them? So there is something called a processor profile. Process profile will help us to understand this. So in order to filter out to look for legitimate process from the suspicious behavior, we need to use some tools. These tools are actually either Windows Task Manager that shows all the applications up and running, all the processes, as well as the process hacker. So let's say I have here Windows. You can just like you can download a tool called Process Hacker from the internet and run it. You will see a lot of processes here, okay? Or you can open the Task Manager. Task Manager. This is the Task Manager. You will see all the applications here and all the background process. We have here 40. Whenever I open anything, let's say I will open any new application. Number of a process will increase. So let's say snipping tool, new processes added. And let's say I open calculator, new process added. Let's say whatever I am like doing here, it will be like writing something in the memory. Let's say I open this game, a new process will be added. So here, these tools will help us. These tools, the Process Hacker and the Task Manager, will help us understand like all the processes here. Okay, as well as we will be able to see the different type of applications. Here, see applications, and here are the background process. The same thing, Process Hacker will help us to understand what kind of a processes and what are the process ID, the CPU usage. Is there a process that consume a lot of our CPUs? Maybe this is a suspicious things that we need to consider. So there are a lot of things. And also I can search by a specific process such as LSAS, LSM, service or services. I can search SVC hosts or host.exe. So I can search for a specific name process. So I need to use some tool to filter out these processes. So we can use either Task Manager or a Process Hacker. Now, here is the most important point that each process has a profile. It's kind like we have here multiple processes, Each process has a profile, okay? It's like a fingerprint. If this fingerprint has been changed, this means that there's a suspicious activity here, okay? So I will tell you, we will start explaining each process one by one. So let's go to the first process. System.exe. What is system.exe? System.exe is kind of the heart of the Windows, okay? So think of system as the heart of Windows. If it stops, Windows is dead. So it is a very critical process. It's the core system process that runs the Windows kernel. So it's kind of so Windows kernel. What does Windows kernel? Because this process runs the Windows kernel. So what is Windows kernel? Windows kernel is actually manager communication between software and hardware. So kernel is kind of something in the middle. So here is the kernel, okay? And here is the software, and here is the hardware. System, actually, it runs the Windows kernel. It runs this. And what does the kernel do? The kernel has full access to hardware and system resources, has full access to all hardware within the system. CPU, USB, CDs, hard disk drive, RAM, everything. And who runs the kernel is actually the system.exe. And it handles communication between hardware and the software, because here's the position of the kernel, and it controls access for sure to the memory, because it is actually it is a hardware, and it runs a lot of processes based on the running software. So what is the profile of the system? Let's look first to the system here. So let's like open the process hacker and type system. Okay, I will type system.exe or system. Okay, so I will see system here. Okay, so when I click on system, I will see some information here. So I will see that it starts at the beginning, the very, very early beginning, which means that it starts at boot. When I boot the system, when I boot the Windows 11, when I boot it, system will be directly running to manage, to run the kernel and manage the communication between the software and the hardware. This is the first profile. It runs, or it starts at boot. Another thing that we need to know, that some process has parents, some process has children, some process has no parents. So what's the profile of the system? Does it have a parent? Actually, when I say parent here, system has system idle process 0. Actually, it has, this means it has, and in the previous Windows versions, such as XP, Windows 7, etc., it says that system has no parents, okay? But in Windows 11, it says that the parent is system idle process. Okay, and this means that usually when I see something like this, we will say that, okay, it has no parents. I will show you some services that has parents here. So the parent is a specific process. It will tell you that service.exe has this parent, this one. Okay, so this process has this parent, but system usually has no parent. Even the system idle process, which is process 0, this means that it has no parent, okay? Also, another thing of a system, it has only one instance running. So this means I cannot see another system. So if I see multiple systems, this means that there is a problem. So I will tell you, for example, here, we can see CBT, SVC host. We have multiple instances, but in system, we should have one. If I see multiple systems, oh, this means that it is a suspicious process. So the normal thing is that we need to see only one instance. And when I click on the system, we need that it runs, or the directory from it is actually Windows System 32, a new technology operating system kernel.exe. So usually this is the actual path of the system. If I see it running from different path, this means that there is a suspicious activity. If I see system runs from C Windows System 32, oh, this is suspicious. If I see C Windows System 32 and then backslash and then kernel.exe without NTOSE kernel, oh, this is suspicious. We have to see it running from this specific path. So when I go to the profile, we will see that it starts at the boot. It has no parent, or it has 0. As a parent, we should only see one instance, and it runs from NTOSE kernel, which stands for Windows New Technology Operating System kernel path. So this is the actual path. If it runs from a different path, we should not trust this process. Okay, let's go to the second one. So yeah, one more thing before moving, this is a very critical process. This means that if I try to terminate it, it will not accept. So let's say that I have it here, and then I will say terminate. It will not accept. So do you want to terminate the system? You are about to terminate one of the more system processes. Are you sure you want to continue? It will not allow me to do so. Unable to terminate the system. It's a very critical core function. It runs the kernel that manages the communication between the software and hardware. So we cannot do this. It's not a user level process, system process, so we cannot terminate it. Okay. Now we have another process, and it's very core important process, which is Session Manager Subsystem, SMSS. So, sorry, we have here, yeah, SMSS, which is Session Manager Subsystem. So what is this? It says that it is the first user mode process started by the kernel. So when the system runs the kernel, now we will have the SMSS. So SMSS, it's important is that it creates something called environment variables. What is environment variables? Environment variables are like, do you know when you sometimes, for example, open an application and then you don't save it, it will be saved in the temporary. So it will be temporarily saved in a temporary folder. So what is this system environment? Let's check the system environment together. So I will type, for example, system environment. Yeah, here's the system environment. Okay, so here's the system environment. So what can we see? Then I run it again. I don't want the property. I want to edit the system environment. So the system variable, sorry. Okay. Yeah. So actually SMSS, which is Decision Manager Subsystem, it creates the system environment variable. So there are some environment variables such as the path, the temporary, the temp here. So there are two different types. We have something here called user variables for me as a user, and there is something called system variables. So as you can see here, we have temp and TMB, where temporary files are saved. Just like if I have any temporary file, it will be saved here. What is the path? The path is like where Windows look when you are running any command. So the command line or the command line will be running from this path. Okay. What is the system variable or environmental variable. We have a lot of things. We have here, for example, command specification. So generally, regardless of this user for the system variables, it run the command from this path. Also, we have here operating system where we're running actually Windows NT, Windows new technology. We have, for example, number of processors we are running actually for the processors. So these are environmental variable that should be configured while it should be very well configured, okay, to not affect the system. So who is responsible for the system environment? The SMSS. SMSS, it creates the system environment variable, and we can see it in the system environment. It's very important because environment variables are variables that describes the environment in which the program runs. So they are used by all kinds of programs to answer questions. So sometimes I'm running PowerPoint, sometimes I'm running Windows, Word, sometimes I'm running any application. So where are the temporary file of this application should be stored? The person or the entity that answers this is actually the SMSS because it is responsible for the system environments. So it will ask several questions: what computer I'm running on, which user is running me. So the application will ask itself, which user is running me? Is it user 1, user 2, user 3? This will be found in the user variables or the environment variables. What's my current folder? Where's Windows installed? Where are the temporary files installed? So all this information will be answered by SMSS that's responsible for the user variable and the environmental variable. They should be well configured in order to run other applications smoothly. So let's say that we can here edit the variables of our account. So here's for example, the user, where are the temporary files stored, and here the system variables. And if in case we did not configure this correctly, the application will not be running smoothly. So for example, what happened if environment variable are not correctly set in Microsoft Office Word? The Microsoft Office will not work. It will say, okay, Word couldn't create the work file. Why? Because we need to check the temporary environment variable. We need to set where is the temporary path for Word files, because we need to have all these values complete before running any applications. Therefore, SMSS is very critical actually process. So where is the SMSS? Let's go to the SMS, and here we will explain its profile. So here's SMSS. So we'll go to this one. I will type SMS, sorry. SMSS. So here's SMSS, okay? So what are the profile of SMSS? SMSS, its parent is actually the system, okay? Because I will show you here, the parent is system. The parent is system. So if I say the parent is SPC host or Explore or any other thing, it would be a suspicious process. So I should usually see the system. Another thing, it should it starts immediately after the boot. So I should see it at the early beginning, not the last at the end of the applications. Also, it should run from this path, C Windows System 32, and then this service. So the path actually is C Windows System 32. So here, system has no parents or has 0. And SMSS, the parent of SMSS is actually system. What I like in Process Hacker, it will show you the children and the parent. But in the other one, let's say, the task manager, it wouldn't show you this. So it's not easy to show you. It will show you all the processes like this. But what I like in Process Hacker, it will show you, for example, this is a child or the parent of this is this, the parent of this is this, the parent of this is this, the parent of this is this. So it would be easier to know that the relationship between the process. So the parent of SMSS is actually a system. Parent is a system, it starts immediately after the boot, and this is its path. Okay. What about Windows login? Windows login is very critical. Also process. From its names, you can understand it is Windows login. Okay, so it's kind of Windows login. So from the names, you can tell that it is responsible for loading user profile on login. Once I log in to the computer, this process will be up and running in the background. You will not open this process. No, it will be up and running once you log in to your account. So it's responsible for loading user profile on login. And it manages an interactive user login and log off on Windows subsystem. If I terminate it, it will log me out from the account. Okay, so yeah. Okay, so I will go to show you the profile of it. So I will go to the Windows login. I should see it's also at the early beginning. Here's the Windows login. No, this is Windows initiation. So win log. Yeah, here's the win log. I would like to see it here. So here's the Windows log. Okay, win login. So when I click on it, what are the common profile? The path of it is similar to SMSS as C Windows System 32. It does not have parents. So the parent not existent process. So we should see no parents or no parents shown. Parents is not shown, not existing process. So there's no parent shown here. Non-existent process. This is similar to like the parent is not shown. Okay. So there is no parent of it. What other thing? Yeah, it has some children. Okay. It has some children. It has this and this. Actually, what you can see in the slides, it will show you that there are some children. I will show you this children. The children is login UIXEE and desktop Windows Manager.exe. However, we will see that this is actually happened, I think, in Windows 7 and 8. In Windows 11, we will still see this process, but we will not be able to see this process. There's another one instead of this process. Okay. So we will see the desktop Windows Manager and we will see another process. So here we will see the desktop Windows Manager. Desktop Windows Manager is responsible for drawing and managing the Windows graphical interface, and animation, transparency, visual effect. So this is the desktop Windows Manager. And if we, for example, try to stop it, the desktop visual break and disappear, but the system itself is still running. So if I try, for example, to terminate it, say terminate, it's enabled because it would affect the whole things here. Okay, so we will not going to terminate it, but previous actually Windows, it allows the user to terminate, but it will affect the visual of the device. Another one is font driver host. So what's font driver host? From the names implies font driver hosts is actually running in the background to safely load all the fonts used by the Windows and application. So here there are a lot of like fonts here and there. So those fonts who are responsible for loading all the fonts is actually this process, the font driver hosts. and this is the front driver host. The parent is actually WinLogin. So this is it. So if I try, let me try to terminate it. If it will either log me out from the account or it will not allow me to do so. So to terminate, if I continue, this would affect. Let's try to see how it goes. See how it goes. It affect the whole Windows. It affect. I think it logged me out from the Windows. Okay, I'll run it again. So Parallels is actually a very good application that allows me to run Windows suspended. Okay, I know it's suspended, please. Okay, to trial. So just to link that Windows login, when I terminate Windows login, it will look me out from my account. This is just to prove this point. Okay. Hey. Where's WinLogin? This is WinLogin. Okay. Let's go back. So Windows login, parent is not shown. This is the path, and it has two actual children, login UI and desktop Windows Manager. But in Windows 11, we have actually the front driver host and the desktop Windows Manager. Okay. Also, we have Windows initiation. What is Windows initiation? It is Windows startup application. So actually, this Windows initiation, Windows startup application, it has actually, it has a lot of things, and it has a lot of children. We do care about its children because its children are very important, such as LSM, LSAS, and services. So we will see here Windows initiation. Here's Windows initiation. And it will have a lot of services here. So we will see here Windows initiation, and it has some profiles such as it should again run similar to the other previous from the same path of previous process, such which is the C Windows System 32, and it has no parents, and it has three children, and it's very critical that it has three children, the LSAS, LSM, and service. And one more important thing is that we should have only one instance of Windows initiation. We should not see multiple Windows initiation. So if I see any more Windows initiation, this means that, oh, there is a suspicious activity here. So only one Windows initiation. So we should only see one instance up and running of Windows startup application. So now we will see different samples, and we will try to see what are the issue within this thing. So let's say that I am running Process Hacker or Task Manager, and I have seen all these processes, okay? Okay, system is part. Let's review what we have learned. We have seen system, and system we should have only one instance here, right? So there's no more system here. So no more system. And system, the parent has no parent. So system idle process, so it has no parents. Okay, system idle process or process zero is kind of has no actually parent. Also, SMSS actually is his parent or its parent system. Perfect. What other information about SMSS? So this is SMSS, so everything is normal. What other things that we have also learned? We have seen Windows login. Where's Windows login here? Here's Windows login. Perfect. We should, well, here's Windows login. it's okay, it's up and running. We also take Windows initiation. So we should see only one instance of Windows initiation. So here's Windows initiation. But is it the only instance? No. We have seen, as you can see here, here is Windows initiation, and here is Windows initiation. So this means if I see something like this means that one of them is legitimate. One of them is legitimate. Okay, one of them is legitimate. And another one might be not legitimate. How can I differentiate between them? I should actually see these things because sometimes malware hide themselves in such services, a legitimate service, to hide from the hide themselves. So they hide themselves or inject themselves in some processes in order to in order to keep them unseen from the regular user or from the users. So seeing this is abnormal because we know that from the profile of Windows initiation that we should see only one instance. Okay. So this one is actually the things that we need to consider and investigate further. Okay. Now we will talk about LSM. LSM, LSAS, and service, all of them are actually children of Windows initiation. So we can see here the local session manager. So the local session manager actually is manage the user session. So it manages connection related to server on host machine. So any login, log off session, switching, and remote desktop, if I connect through my computer remotely, what is the service that is responsible for this is actually LSM, which is the local session manager, because it manages connections related to server on host machine. So, okay. So here is actually the parent of LSM is actually Windows initiation. It starts immediately after the boot, and this is the actual path similar to the previous one, and we should only see one instance. Okay, so I will see if I will be able to see it. Okay, so now I should see actually the LSM under the Windows initiation. However, sometimes we cannot see it because so previously we should see it in Windows 7 and Windows 8. We will be able to see the LSM, but in the Windows NT we will not be able to see the LSM because it is actually a protected system process, and modern Windows hide the critical core services to prevent tampering with. So it runs silently in the background. It's not meant to be interacted with or manual or stopped. So you might not be able to see it. But if we run previous Windows applications or Windows operating systems, we will be able to see the LSM. Or sometimes if we are actually so we might not be able to see it in the newer version, or sometimes if we are actually connecting to a remote service or a remote through our remote desktop, we will be able to see the LSM that manage the communication. So sometimes you will not be able to see it unless you have a clear connection remotely, or it will not be shown in the updated version of Windows. Okay, so after the LSM, after the LSM, we will be talking about another service, which is LSAS. So this is LSAS, is very critical actually service. So LSAS, what is LSAS? LSAS is Local Security Authentication Subsystem. It's very critical service. Very, very critical service. Why? Because it's responsible for user authentication, password validation, and security policies in the Windows. So if I have multiple accounts, and how can I Like I have now one user, but what if I have multiple users? How can I, for example, if I access my account as a Noura and I provide my password, how do I ensure that this password provided is actually correct? LSAS is responsible for the authentication. So it's responsible for user authentication. So LSAS is actually the brain of Windows because it controls the authentication, the login, the security policies, etc. So when we type our password to log in to our account, LSAS check if this password is correct and decide if the access is actually allowed or not. So we'll go here to LSAS. So here's LSAS. So the parent is Windows XE, and here's the same actually path as before. Um, I would like to go something. Um, yeah, if we go to the service of LSAS, I just want you to be very clear about this. If I go to the services of LSAS, I will see something called here key ISO. I will see something called SAMSS, which is, what is this? Security Account Manager. So Security Account Manager, it's kind of, it manages the local user accounts and passwords stored on the system. So when Windows checks whether the username is accessed, if the password is actually correct, etc. So SAM or the Security Accounts Manager service provides account information actually. Yeah, here is the Security Account Manager. Also, we have here key ISO. So key ISO protects the encryption key and isolate them from directly accessed by applications. So if there is any encryption key, it will be isolated from the applications. So when BitLocker or certified-based login is used, key so the key ISOs actually safely handle the cryptographic keys if there is any cryptographic keys there. So all the keys will be stored here, okay, for an encryption, decryption. But the accounts for the Windows, it will be stored here. The last thing is the credential manager. So credential manager or the vault SVC, it's actually saved some credentials. So, for example, you have several applications and such as Outlook, the Wi-Fi, different websites. So sometimes it requires some passwords. These passwords are actually stored in the Vault CVC. So here's the credential manager. It manages and stores a lot of passwords there. But here for the accounts to log in or log out from the Windows itself, and here all the keys for any encryption. I just want you to connect the LSAS with the security aspect by checking these services. Okay. So even terminating it is not possible. If I terminate it, this means that it will, I think it will not be able like to verify any user or anything later. Okay. So we have also so we said that under Windows initiation, we have an LSAS, LSM, LSAS, and services. So services, what is services here? Services is very important because it is the service control manager. It either starts, stops, manage some Windows service in the background and when the system is run. There is something called services. What are these services? I will show you here, okay? I will type services. So I will type here services. Yeah, here are all the services by Windows. So there are a lot of services here. For example, some services actually related to the network. So, for example, DNS client. Do you want to run the DNS? It is running. It is up and running. I can actually click on it and stop it if needed. I have here, for example, uh, IB security, IB security policy agent. It's running. I can actually stop the service or restart the service. I have also DHCP. So there are a lot of like services there. So I have DNS, I have Bluetooth, for example, I can turn on or turn off Bluetooth. So Bluetooth support service, it's not running, but I can, for example, start the service. So I can click on start. So it takes time to start it. So now it's running. I can also stop it. It will take time and then it will be stopped. So all these services that exist here managed by something called services.exe. So this service, it is a service control manager, which is responsible for running, ending, and interacting with system service. System service, it's very critical. It's not user service rather than system services. So we can see it all as I showed you here. We can, and we will see the actual profile of it. So we will see it here. So you can see here services. There's something underneath the services. It includes the services include the system service and the user service, by the way. Okay. So when I click on the service, for example, we'll see that the parent is actually Windows EXE, Windows initiation EXE, and we'll see that start immediately after the boot. They have the same path as the previous services. Okay, so we will see these things. Yeah. And under services, we will see many other things. We'll see many other things. It includes system services and user services, okay? But I will see a lot of services here, a lot of services. A lot of services. Any services running, it will be shown here. Security health service, etc. So here is the profile of the service. And we have also tasks host or task hosts. So under the service, we have two services, okay? Under the service, we have two services underneath it, which is the task host and SVC hosts. Okay, what is task hosts or task hosts actually? Task host, as you can see, so task host is actually, task host is an older version or older Windows process. It's used to run in the background and schedule some tasks. It was mainly used in older version of Windows, and the newer version of it is actually task host with W. W means Windows list. So I will show you, this is task host, but we will not be able to see task host. We will see task host now with W. W means Windows list. So let's go here. Have a lot of services. Yeah. Okay, I should see task hosts. It seems there's no tasks host yet. I ran it before and I had it, but actually I wasn't able to see task costs. I usually see task. Yeah, it is there. Excellent. Okay, I saw task cost with W means Windowsless. What does that mean? And what does the task cost does? Task cost means it runs all the scheduled tasks. So if I have any scheduled tasks, any scheduled update, any scheduled tasks, it will be the service that is responsible for any scheduled task is actually task costs. So we have here, I will show you something here called task, task CHD. So here's the task scheduler. So if I open task scheduler, okay, so the task scheduler is actually, it will show you all the scheduled tasks. So one of the scheduled tasks is that there is kind of a scheduled task every day at 2:13. It will kind of do some kind of update. So this is a scheduled task. What is the service that responsible for this scheduled task is actually task host W. Okay, so here you will see only task host, but actually the newer version has W, which means Windowsless. So it's a task scheduler service, which is responsible for running scheduled tasks. So actually, yeah. So when this process is running, it will check this and it will execute it. Okay, so this is responsible for the scheduled tasks. Okay, but the point is that previously we are usually saying only one instance, but in the task cost, we might see multiple. I think we might see multiple task costs, not only one task costs. Yeah, we might see multiple task costs, not only one task cost. So it's okay to see multiple version or multiple sample of task costs. It's okay. This is normal. Okay. Another thing is SVC host. SVC host, what does that mean? SVC hosts means service. It's related to the shared services by a process. So actually, SVC hosts, we might see multiple SVC hosts. So if there are several processes, okay, or yeah, if there are actually several several processes or several services sharing same process, we are actually grouping them by SVC hosts. It hosts multiple service. Okay, it's essential in the implementation of so-called shared service process, where number of services can share processes in order to reduce resource consumption. So let's say I'm running this service, 1, 2, 3. But actually, service 1 and 2, they are using this process. Okay, so SVC host will do kind of, it will group service 1 and service 2, okay, under one SVC host. Why? Because they are sharing the same services. So to enhance the resource sharing, they are actually grouping them by SVC host. Therefore, if I go here and check SVC host under the services, I will see multiple SVC hosts. So see multiple things. And some of them are grouped. The grouped one are kind of sharing service. So it says that. So all of these are sharing similar resources. All of them are actually different to process. They are sharing similar, there are different process, and they are sharing similar services or similar resources. Okay, so SVC hosts, it groups several processes um, together, so they can share resources together. But there are some SVC hosts running alone, but there are some SVC hosts they are sharing several. So these are kind of different application. They are sharing or several sources sharing the same process or sharing, yeah. So if there's any grouping, it will be grouped by SVC host. It's essential that the implementation of so-called shared service process. So actually, we might see multiple instances and used for running several dynamic link libraries. If there's any shared things, we will do the same thing. Okay, so we will see this, and we were trying to know if I have seen this, for example, let's say that I have seen this memory sample. What is the abnormal thing here? So this is an example of, or this is a sample. Okay. We would like to see, is it normal? Is it abnormal? So we need to think very carefully about all the things. So first of all, we need to see all our process. So we see system okay is has no parents or has parent zero, which means no parent. We have SMSS. It's normal. It's the father is actual system. It's normal. We have also Windows login. This is Windows login. Is there any, all of them are actually alone. There is no multiplication of Windows initiation or some SS. Sorry, where's Windows login? Wait a minute. Here's Windows login. Yeah, there's no duplication of Windows. Windows login, it's okay to have multiple login user, so it's okay. But Windows initiation, we should have only one. So here we have only one Windows initiation. If there's any extra, this means it's not acceptable, but we have only one thing. So I just want to write, so here's okay. SMS is okay because we have only one process. I'm running one process for the Windows login. It's okay to have multiple, but it is normal. There is nothing abnormal in it. Actually, we need to click on it to see the actual path to ensure everything is correct. But from this, what we look, Windows login is perfect. What about Windows initiation? Windows initiation is actually is normal because it should be we should only see one instance of Windows initiation, and the children of Windows initiation is LSAS, service, and LSM. So we might see LSM. Okay, so LSM is not here. It's normal. Under the services, we can see SVC host and task host. So we can see here SVC host, SVC host, SVC host, SVC host. Okay. It's normal. It's okay. Okay, here's kind of abnormal. Why? Because we should see SVC host, and the parent of SVC host is actually service. But here, the parent of SVC host is MSDTC. This is something abnormal. We should not see this because the parent of SVC host should be actually the service. Okay. So this is abnormal thing. Also, we need to see task cost, and the parent of task cost is service. However, what we can see here, we can see that task cost and then EX. Why EX? This is abnormal. It tries to be like a normal. So these are the things that we should not accept. So here, the parent of SVC host is this, and this is not acceptable. It should be the parent of SVC host should be the service, but this is not acceptable. Here we should see task host, but why we see EX? This is abnormal. There's there's a spelling mistake here, and maybe this is not a spelling mistake. Maybe the hacker tried to hide himself into a service by keeping the correct one with changing the last few letters or some letters to avoid being detected. It's kind of like when you have seen some phishing links, and these phishing links seems normal, but they are suspicious. So these are the things that we need to investigate further to check whether they are normal or abnormal. So this is not acceptable. I couldn't say it is malicious. I would say it is suspicious, unless I make sure it is actually a malicious process. Okay. After that, we will continue talking about some processes. Few last processes is actually the client-server runtime process. So what's client-server runtime process? Client-server runtime process actually a core Windows system process responsible for basic user mode operation like creating and deleting process and threads, handling console windows, command prompt, PowerShell, etc. Without this CSRS, Windows cannot easily function. So it starts parents is not shown as the system. It starts immediately after the boot. Here's the correct path for it. And if we terminate this, the system will crash and we will see sometimes the blue screen. The blue screen. So this is therefore the client-server runtime process should be protected very well and should not be manipulated. So we can see the as CSRSS. So see here, CRSS, client-server runtime process. So here's the here's it. So we can see that the parent, this is the path. It has no parent or not existent, or parent not shown. Sorry, it has parent not shown. Parent not shown. But let me go to the system. Yeah. System, it will show you 0, which means no parent. The only thing that has that has, not the only thing, but system has no parent. But if you see if you see not existing process, this means that parent not shown. Okay, parent not shown. Okay. And I cannot terminate it, because terminating it means it will affect the whole Windows. Okay. Now we will talk about the last two processes, which is the Explorer and the iExplorer. So Explorer, what is Explorer? Explorer, so here's Explorer. It manages Windows graphical interface, including the user desktop. So previously, we said that Windows login has the desktop Windows Manager. So we need to differentiate between desktop Windows Manager and Explorer, because in the Explorer, it is responsible for the user interface, for the desktop, as you can see here. So here's the Explorer. What's responsible for? It's responsible for the user interface, for the desktop, for the start menu, for the taskbar, for the file explorer here, for many other things. So this is who is responsible for this is explorer.exe. However, we previously talked about this, and I want you to differentiate between DWM. What's DWM? DWM is responsible for the graphical things, the visual things, the visual effect, the clicks, the the movement. So those the desktop Windows Manager and the Explorer are different. The Explorer is okay about the Windows or the desktop, but it is about the taskbar, the desktop appearance, the start menu, and so forth. Okay, so what are the actual profile for Explorer? Actually, Explorer starts from C Windows, and the parent is not shown, and it is one for each login user. So if I have seen multiple user log into the system, I might see multiple Explorer, which means that multiple user are actually accessing the Windows. So here I should see only one Explorer. So this is normal if I see only one Explorer because one Windows or one desktop for one user actually log into the account. Okay, under Explorer, there is something called iExplorer. So, mhm. Mm. Actually, the second service is related to Internet Explorer. Internet Explorer is kind of similar to the Google Chrome, but the newer version of it in Windows is actually the the Microsoft Edge. So here, this is the Explorer already talked. The iExplorer is similar to this tool, which is the Microsoft Edge. So in order to see the iExplorer, I will see if it is already there or not. Internet, yeah, is it there? Yeah. So if I click on Internet Explorer, I should see some services related to the Internet Explorer. So let me type here Internet Explorer. I should see iExplorer. So maybe it is different. So let me check iExplorer. Okay. So actually, iExplore is related to the Internet Explorer. We should link them together. Okay. So, right. Okay. It's responsible for creating Internet Explorer program. So whenever I run it, I should see it. And the parent of it is actually the previous one, which is the Explorer. So under the Explorer, I will see the iExplorer. And here is the path of it, the program file. Okay, not system32. It starts from C program files and one for each login user. So actually, I have tried it before and I was able to see this thing. If you run older version of Windows, you will be able to see it. But actually, what I am caring much is this application, Microsoft Edge. So whenever I like run it, I will be able to see a lot of MS Edge, which is kind of equivalent to iExplorer, or sorry, to iExplore. So MS Edge is equivalent to iExplore. So this is kind of equivalent of it. Okay. So we'll see here. Here's the Microsoft Edge application. Okay. Now we will see the sample. Okay, so we will see the sample. Actually, to make it easier for you before answering this sample, okay, I will answer this sample with you. Then I will simplify the whole thing through the mind map. So we need to check whether each one is normal or not. Oh, first of all, this is the system. Transit from the system idle. This is the SMS. It's normal. What other process we covered? We have covered Windows login. Windows login. Where's Windows login? We have to see here Windows login. Here's Windows login. Perfect. It's normal, correct, not misspelled or not. There's no spelling mistakes in Windows login. We can see also Windows initiation. Here's Windows initiation. What are the children of Windows initiation? Service LSAS. Sorry, we have to see services. Yes, LSAS and LSM. So services here. So services, LSAS and LSM. But actually, LSAS, the parent of LSAS should be Windows initiation. So why I see LSAS is under the service? This is unacceptable. So we need to raise a flag here. So we can say, okay, LSAS, the parent of LSAS should be Windows initiation, not the service. So this is a suspicious one. So this is a suspicious one. Okay. What else? We can say that what else we can notice here? Okay, so under the children of service is SBC host. So we can say that SBC host. Yeah, perfect. Because the parent of SBC host is service. And we can see task SBC host. SBC host, it's normal. These are normal SBC host. And we can also see task host. If it is there, it's normal as well. It's not there, but if it's there, it's normal. Okay. We need to see the CSRSS. If it's here or not. Okay, it's not here. Or it is here. But CSRSS, it is normal to see multiple actually version of it. So it is 1, 2, it's normal. Okay. We also covered the last thing, Explorer and iExplorer. So where's Explorer? Here's Explorer. Explorer, this is okay, but it shouldn't, the parent of Explorer should not be Windows initiation. And this is actually like a red flag. So why? Explorer, the parent of Explorer is not service. Is not service. So this is actually a red flag. So why we have seen this? This means suspicious. And also we can, let's see if there's any other thing here. Yeah. Yes. So here's also tasks host. First of all, why we have to see task host with EX? This is not acceptable. This is wrong. It should be task host, and task host, actually the parent of task host is service. So is the parent of service? Yes, the parent of service, but there is a wrong spelling here. What else? What other things that we can notice here? Also, Explorer and Explorer and iExplorer. So Explorer, it is normal. Explorer is here. Perfect. And I can see underneath it is iExplore. So what I have seen here is iExplore. sorry, I explore, but there is extra ER, which is abnormal. This is abnormal. So we are not accepting this as well. So this is also another thing. So we have here, see, a lot of things. First of all, we need to have the baseline. We have to see the profile next to us in order to answer this. So there are a lot of issues. I know what we have covered is more, but actually, one of the things notable is here, task cost, there's extra EX, and I explore, it should be I explore without actually, without an R, not an ER. An RE is correct, but an R, there's extra R. It's not I explorer, it is I explore. So the R extra is not acceptable here. So those might be also suspicious. So here is, so this is normal, and the abnormal is the extra R. This is abnormal. Also here, EX, also these are some like incorrect parent for these things. Okay, so to make your life easier, I have created this process mind map a long time ago. Okay, and it was based on Windows 7 and Windows 8. The same thing applies, all the things in red. So we have system, Windows login, Windows initiation, CSRSS, and Explorer. The children of system as SMSS, the children of Windows initiation as services, LSAS, and LSM. The children of service as tasks host and SBC host. The thing in red, this means I should have only one instance. The thing in yellow, this means that I might see multiple instances of it. And here are the profile just to to ensure that everything is clear for you. Now, what's the point of all of this? Okay, so what after knowing the process? How can we utilize these things? I will show you now how can we utilize these things. So you need to actually, I will tell you one of the examples, okay? So one of the known malware that affect one of the critical infrastructure in Iran is Stuxnet malware. They actually took a sample from the memory. They captured the memory, and they have created a .vmem or a .mem sample, okay? And then they use volatility tool in order to see the process. And one of the things that they said, injecting into new process, they said, depending on the process present in the system, the malware chooses the host process from the following list. The hacker or the attacker tries to hide his malicious activities inside the LSAS service, which is a system process. So this is very important for you because you need to analyze what are these services, what they are doing. Also, so this is another link, memory analysis of Stuxnet with volatility. So Stuxnet is actually a computer worm that originally aimed at Iran nuclear facilities and has since mutated and spread to the other industrial and energy producing facilities. So actually, you need to download Stuxnet from any memory sample from the internet. Once you download it, you need to use a volatility tool. How would you use volatility tool? The simple answer is to go for Kali Linux. Okay, and you follow the steps of downloading volatility and then use volatility Python. Actually, I'm using Python 3, so therefore I will say Python 3 volatility.python and then -f for the file. So I will go with you through this. And then, so Python, and then the file is actually the malware.vmem and image info. Image info means show me this memory belongs to what operating system. So it will tell you that, okay, this memory that you acquire are actually belong to Windows XP. Sorry, it says that it suggests several suggested operating system that might be related to this memory. It says, okay, this is either Windows XP, SP2, or Windows XP, SP3. So, but all of them confirm that this is belong to Windows XP. So I know that this memory belongs to this operating system just from running volatility. Also, how can I know the malicious process? By running process scan. So I can use also here Python 2 or Python 3. Then I will run the Python application, then -f, then the file, the same thing. And then -- profile. After I know what is after getting this suggested profile, I can choose one of them and then type it here. Windows XP SP2 x86 and then PS scan or PS scan. Okay, PS scan means a process scan. Process scan. So this means that show me all the processes running that were running within this memory. It will show you all of them: LSAS, Windows Login, SVC host, and many others. Okay, some of them are normal, some of them are abnormal. How can I know? It is good to analyze the trees. So to know the children, the parents, etc., the parent to child relationship. So it's good to show the process tree instead of this. So I can see, okay, can you type, this is the this is Python 2 or Python 3, then the Python code, then -f, then the same name, and then the same profile, and then PS tree. It will show you here. Okay, it will tell you that SMSS as the parent is system, Windows login as parent of. Like, it will show you everything, and then you will analyze whether there's normal or abnormal things. So we can see some information. Yeah. So it is good to see how it goes. For example, we know that we need to see only one version of LSAS, okay? But here we are kind of please show me all the output for better visibility. There are a lot of process, and I can run this command. I can say Python and then -f and then the name of the file, and then with this profile, show me the trees, and please show me only the LSAS, Windows login, and the services. Why I want these things? The LSAS, Windows login, and the services. I know that the LSAS and the services, I should see one version of or one sample of LSAS and one sample of services. If I see, because they are in red, see, they are red, the LSAS and the services. If I see multiple LSAS, this is something that we are not comfortable with. Okay, we have seen multiple LSAS and Stuxnet malware, and this is not acceptable as well. So by this, you will be able to analyze such malware, okay? And I do recommend you to go through, so for example, here, in Kali Linux, okay, there is actually an application, or not a website, called Memory Forensics, okay, Master the Art of Memory Forensics. It has a lot of samples, okay? So here's the samples, Linux Memory Forensics Challenge. It will show you a sample or a memory from a Linux operating system. You can read more, you can download it, you can analyze it using volatility tool. There is another one, Memory Analysis Case Study. It is a recent one. You can and download it and try to analyze it, and so forth. So this is a very good application, Memory Forensics. This is a very good website, Memory Forensics, and it has lots of samples. Some of them, when you are trying to download it, it will direct you to another application or to another website, such as Cyber Defenders. Also, Cyber Defenders has some labs, and some of them has some memory samples. You need to read it very well and then download it and try to analyze it. So that's all. In order to understand the whole thing related to the this lecture, I want you to understand this very well. Once you know this very well, you will be able to analyze whatever memory sample that you have, because this is the profile, this is the kind of fingerprint that differentiate a process from another process. That's all. I hope everything is clear, inshallah. Thank you so much.